on that. So first off, let me put some stuff back up here. Let me get this particular thing off the screen. All right. Give me a second to.
You got so upset.
What do you got?
Yeah, you got messed up.
Okay.
That was nervous.
Okay. All right. Now then, y'all. Okay. Here's what we're gonna do. You might see my clicker. I put stuff down all the time. Okay. Thank you. Good. All right. Now, here's what we want to do. Hey. What are my rules? Pass, right? You know your passes. Okay. Yeah, you can go take care of your dad. I got it. I know how mommies and daddies can be. All right. But if you're not on it, then you wouldn't even know. Okay. Now then, let's do this here. Okay. First off, going across here, everybody. Hey, we're going to do days, because that is in a sense our domain. Day 0, we have 1, 2, 3, 4, 5, 6, 7, 8, and hold on a second. I know Dan's filming. If y'all would appreciate, Josh, would you hand one of these to everybody now, please? And bring this right there. Okay, yes.
Should we put this on the actual graph?
Well, actually, not on this graph. I'm handing him out your notes. But I didn't want to put the notes out there quite yet, so I want you all to make a prediction. Now then, y'all, let's do this here. I'm going to probably put 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22. There we go. We'll kind of do it like that. All right. On day 0, how many people were affected? 1. Okay. On day 1, we had how many? Wait a minute. I did every 2. Sorry. I can't even, math teacher and can't count. All right. On day 0, we had 1, right? And then day 1, we had how many? 2. Right? On day 2, we have how many? 4. Day 3, 8. So 2, 4, 6. Yeah, write this on the notes. You can find it or on the back of the paper if I don't find any room. I'm sorry. 8. So day 3, we're at what? 8. Okay. Day 4, we're at what? 11. So that's going to be about right here between those two. 5 will be 18, right? We got way up here. Okay. Then what happened on day 6? It was what? 20. 20. Day 7 it was 20. And then it was what? 22 on day what?
28.
18. So the graph looks something like what?
Damn, everybody died pretty quick.
I mean, I don't have to do that, but it kind of looks something a little like that. This one's a little more sloped than what most of them are. Everybody see that? Here's. So here's our graph. Like that. Everybody have that? Does everybody kind of have that copy down? I guess I wasn't very smart. What I should have done is real quickly, I'm going to do this right over here on the side where I have a graph. I'll make a little small one so I can use my little stuff here. The graph looks something, should look usually something like that. Okay? I'm going to kind of do that just as a quick little side note. So, everybody, I'm going to erase this just so I can have my screen and stuff. Everybody got it kind of copied down what the graph kind of looks like? Okay? So, what we want to do here is the following. And it does work much better with this the screen right here. All right, now then. All right, so here's what we have. That's what we did. So here we go, y'all. There's kind of what a sample most logistic models look like. Okay. Now ours is not over here because we're dealing with real world problems. Maybe not a zombie, but y'all, that's a great key of like what a virus might look like when it attacks people. Okay. Because here's my question. Okay. We had a rate of growth increase. We had a rate here where the growth is still growing, but it's not growing at what? Quite as what? Fast, right? But here's my question to you. Why, at the end, why does the graph look like this?
It starts like, I guess, in the same places.
I don't know. Ideas. It's just, why does the graph look like we did here, as we did plan this activity. What are some reasons why the graph, like, say what?
Are you asking why the graph flattened at the top?
Yeah, that's one of the questions I'm asking, yes. Why did the graph flatten at the top?
Because there's no more human beings left to infect.
Because there's no more human beings to infect. And y'all, this is what's kind of funny. The graph kind of starts out like, I think, how did it start out? Kind of flat, and then kind of started to what?
Increasing.
Grow, and it started to grow. Now, if the graph went on forever, just remember what type of graph it would look like if that part went on like that forever. What kind of graph is that? It's exponential graph, okay? How come, and I want you to think about this here, in real world problems, can things grow exponentially really forever?
No.
Why not?
Okay.
There's always
Sure he does.
There's always a limited amount of people, limited amount of resources. So even though we draw exponential graphs from a math theoretical standpoint, when you get into real world problems, at some point they start to what? Flatten out. That's a logistic model, a logistic growth model. Because we don't have what? Unlimited people, unlimited resources. That's why the graph flattens out. Okay? So, titer spread of a virus. So here we go. I have a question for, I think this is in the notes. Okay? So here's the formula for this particular one right here. And this is something that can happen actually on a college campus sometimes. All right? I want to say this here. It says the college will cancel class when 40% more of the students are infected. So how many students are infected after 5 days? Well, and because I'm looking at my time here, I'm going to do this. For time's sake, I'm going to do the following. I want you to do something before we go. If I plug a 5 in, which in basically this formula, to do the formula, I'm just going to take 54, so how many students are affected after 5 days. But they'll cancel classes when they get to 40%. So think about it. What's 40% of 5,000? 2,000. So basically, when 2,000 equals that, and basically you would have to multiply the bottom times the 2,000 here to get, then I divided by 2,000 to get the 2.5 on the right, and I multiplied by that to get that on the left. Then you minus the 1, divide by that 4.99, and I'm going to tell you, we haven't got to this part yet, but we're going to be learning like this next week how to do and solve this particular part. But right here, after about 10 days, 2,000 people should be affected if the virus grows at that rate. Now that's just kind of like, yeah. But here's the part I want you to do. On the logistic model here, I want you to predict. You have 50 right here. See that graph right there you have with the paper I gave you at the very beginning? Everybody see that? There are 50 numbers there. What I want you to do with your group, and Ed, when you, tell us, I do that. You can join a group if you would like. And what I'd like for you to do is this here. Your assignment is this here, all right? Is I want you, because you need the random calculators, and I don't know if I gave you quite enough time, but to randomly do one with 50, first off, before you do it, I want your group to predict how many days you might think it take for all 50 people to get affected. It took what? How many days did it take for us to get affected on?
8.
No, there's 22 of us, so how many days? 8. So now there's 50, so make a prediction. So what I want you to do is predict how many days you think it'll take all 50 to get done, and then I want you to run this model to see if your prediction is correct. All right? Now, I'm going to tell you this here. That's why, excuse me, hey, shh, I know y'all, I know we're going to run out of time and not probably like, we can finish up, but that's why you have this here, because you need the what? Calculator to do the what? Random generate numbers. And the way you do it is, on your calculator, hit the math button. And I don't think I had that typed up here. Have the math button, hit the math. It's written on this paper here I gave you. And you arrow over to PRB, math, arrow over to PRB, and I think it's option 5. I think it's option 5, thank you. Tell it's option 5, and what you're going to have to do is this, all right? You're going to generate your numbers will be 1, 50, and then the first day will be 1. And that's the number you're going to mark out. But as you do that, you're also going to need to keep a what? A table of your days, got it? You need to make a table. If you haven't used this table, you can go ahead and what? Use what? That one. You didn't use this one on the little thing we did. You can use this table right here. So if you would do that, that's what I want you to do. I want you to make a prediction. So first off, let's hear. Anybody want to make a prediction out loud in front of everybody what they think it might be?
16 days.
16 days. Give me a-
18.
I have 16,
I say
15,
17. 14, 17.
20, we hear a whole bunch of different numbers, all right? So,
Right.
y'all, hey, this is what I want you to do. This is your particular, there's gonna be your exit ticket. I'd like to kind of hand this out, but I don't think there's gonna be enough time for you like to get this finished. So, but I do want you to try to do this. If you have a calculator, make a prediction, so we can discuss this when we come back on Monday, guys. Also, hey, keep the other papers. Keep the other papers, we'll go over this stuff on Monday afterwards, all right? So, that, you go, yeah, we're done.
Is this a grade?